Hey guys, how's it going? All right, so we need this homework to move on to our next homework. So I want to point a couple things out on this graph that we did yesterday. So if you notice that the places that we said were solutions were points of intersection, right? And if we're looking at the two functions from top to bottom, the blue part, the exponential function, is above the linear, the line, right? All the way until we get to this point. And then I hope you can see it. If you can't see it on mine, hopefully you can see it on yours. After this point, it switches. The pink is now higher than the blue, right? And then we have another point of intersection, and then guess what happens? It switches again. The blue is higher than the pink on the y-axis, okay? So that's what we're going to be looking for when we're solving the systems in a different way, okay? So we will go over answers to this tan sheet and turn it in on Friday. It seems like you guys got this pretty well because most of you finished it in class, but so let's take a look at this. First, I should have changed the tables here. Let's extend this out. So this first y is going to be the y equals 2 to the x, and this next one is going to be negative 3x minus 1. Okay, so let's make our table larger. Okay, and then we're going to pick some x values. What x values do we usually pick? Do you remember? So I'm going to do this in pencil because I want to make sure that I don't, if I need more x values, I can erase. Hopefully you can see that. Oh, it looks like we have more space just in case. Okay, so we usually for our exponential functions pick negative 1, 0, 1, and 2. So take a minute and fill in the y values for that exponential function. So you should have gotten 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 to the second is 4. Okay? Maybe we'll need another one. We'll find out in a minute. So now take a minute and fill in for these x values over here. You're going to plug the x values into this equation and get some y values for me. Okay, so when you, let's write this out. When you plug in a negative 1, you get negative 3 times negative 1, yes, you can see that, minus 1, right? Plugging a negative 1 in here, x equals negative 1. So that's just 3 minus 1, that's 2. Plugging in a 0, that's easy, right? Because this goes away, so you just get negative 1. Plugging in a 1. Negative 3 times 1 minus 1. That's negative 3 minus 1 is negative 4. And then plugging in x equals 2. Negative 3 times 2 minus 1. That's negative 6 minus 1, which is negative 7. Okay? So the next thing I want you to do is, I want you to compare the y values. So which one is larger? Just like we talked about on the graph. We said first the blue was larger, right? This is like positive y values and these are negative y values. So larger, higher on the graph. And then the pink was higher. The pink had larger y values. And then the blue had larger y values. So the blue was larger. So let's analyze this in a different way. Which one's larger? This one. 2 is bigger than 1/2. Which one's larger here? 1 is bigger than negative 1. What about here? 2 is bigger than negative 4. 4 is bigger than negative 7. So it switched from this one being on top to this one being on top between negative 1 and 0, right? Larger, this guy, the line was larger, then the exponential function became larger. So determine between which two x values the two functions intersect. When it switches, those are the x values that you write down as your answer. So between -1, and 0. Okay? So you're going to do the same thing on these. Make sure you extend out. So this would be your 1/2 to the x. Make sure you extend out your table for the other function. Sorry, I don't have that for you. I meant to edit that before I made these copies. And then fill in your x values, plug them in to find your y values, and then figure out where it switches from one of the functions being larger to the other function being larger. Okay, so we'll go over this and the tan sheet on Friday.